This is unit 6H. It deals with capacitor and wave rectification. So here we've got two capacitors, one that's being charged and one that's being discharged. So we've got a cell here, and it basically pushes the electrons out the negative side and onto this plate. So the capacitor is this thing here, and here on this side the electrons are leaving. So it's a bit like static in that this ends up being positive. Now the reverse is happening over here. We have a resistor here, and the piled up electrons are trying to repel each other, and they all flow through the other direction until it's all evenly spread again. Now here we have something called half wave rectification. It involves a diode. We've got the symbol here, and then we've got more detail here. It's very like the transistors we met earlier. So we've got two bits of silicon, one that likes to give electrons away, the negative one, and one with these things called holes, which naturally wants to grab hold of the electrons. The net result is that electrons can pass from left to right in this particular case, but they can't pass the other way. So we see here, when we've got negative on this side, we're pushing electrons in, that's fine. When we've got negative on this side, we're trying to push them the other way, then there's a barrier. Now the net result of this is that if we input AC, which is one way then the other, one way then the other, we can see our classic AC signal here, half of it's going to be blocked. When it's trying to go the other way, it's blocked, and we end up with this signal here. As you can see, half of it's missing. Now full wave rectification is more desirable because we're keeping more of the energy. So we start with AC again here, and we send it to this. It's called a bridge, and it's a bit complicated. You've got to imagine 50 times a second direction changing, and here on the left we've got one direction showing, and on the other we've got the other direction. But imagine your mind flicking between these two 50 times a second. So here we can see the current coming in. You can only go this way, and it ends up as DC, and the DC coming the other way. Again, it goes along here. It doesn't go these ways because the potential, the energy is the same here and here. Reverse situation, again, one-way gates. But the key thing is this is always going in one direction. So that is going in the same direction as that one, but this one is changing. So this is going to the left, there it's going to the right. The net result of all that is that we get this here, full wave rectification. So the ones that go below the line effectively go above the line. Now the next stage is to combine that with a capacitor. This is the symbol for a capacitor. So these peaks, when we have these peaks, some of the electrons go down here, they're stored here for a fraction of a second, and then they're released back when there's a slack period. And the resulting trace is like this. So we've got these peaks that are now smoothed off, and lots of electrical devices function much better when we have this more reliable, steadier, direct current.